In this figure and graphic, we want to look at the breathing cycle, the cycles of inspiration and expiration. At the top here, on the left, we're going to have air moving in. And what we want to do is examine the pressure gradients required to generate that air movement. We'll look at the exact opposite over here on the right during expiration. Now, we can see that lung volume down here at the bottom rises during inhalation, that of course makes sense, and falls during exhalation. To generate those volume changes, we have to have a pressure gradient between the atmosphere, which is a constant in the red line here, at about 760 millimeters of mercury. We're using it as a reference, so we're going to call that 0. And then we have to have an intrapulmonary pressure that goes below and above that. Well, how does that occur? Well, the lungs contain no muscles to generate air movement in or out. They are entirely passive in this action, but they are stuck to the chest wall and the diaphragm by the intrapleural fluid, right? The pleural fluid in the space between the visceral and parietal layers of that serous membrane. And what that does is it sticks the lung to the thoracic cage wall. That means when we actively, using muscles, change the thoracic cage volume, we also change lung volume. Well, then we just need Boyle's law, which states that pressure and volume are inversely proportional. So on our left here, we're changing thoracic volume to change lung volume upward, right? So our volume goes up, our pressure goes down, right? So you can see our blue line going down, right? We now have a gradient favoring air movement from outside, red, to inside, blue. During exhalation, those same muscles relax. The thoracic wall comes down, the rib cage collapses a little bit as the ribs come downward. The diaphragm relaxes and goes back upward. This means that thoracic and lung volume decreases. That, of course, increases pressure in this inversely proportional relationship. Now we can see that our intrapulmonary pressure is rising above that of the atmosphere, right? And we now have a gradient from inside greater to outside lower, driving our air movement. Now, finally, intrapleural pressure. Remember, that's that pressure in the space we've shown here, right, in the yellow. And that has to remain negative all the time so that the lungs are essentially sucked onto the surface of the rib cage. This is made possible by the elastic tissues of the lung wall that tend to constantly pull away from the rib cage. This generates a negative pressure in this space, keeping the lungs attached to the thoracic wall. And that's true despite fluctuations in it, no matter whether you're inhaling or exhaling. If that pressure ever becomes positive, we're going to tend to detach that lung from the wall, causing what's known as atelectasis, or collapsed lung.